All right, so I didn't get any questions or any emails, which kind of makes sense. Orgo 2 just took their exam, finished their exam yesterday, and Orgo 1, y'all are kind of in the first week of materials, which is just naming, which is a lot easier to work with. Got any questions? I'm here to answer them in the chat. I do want to comment to the Orgo 2 students, since I'm guessing you put off the discussion board for this week, because it was a long discussion board. I don't need the cis-trans and I don't need the RS for the aldol addition and condensation reactions. You're always, pretty much always going to get the trans conformation when you work with the aldol condensation. And when it comes to aldol addition, you're going to get the racemic mixture of the R and the S alcohol that's produced. So really the big thing is getting the compounds just named without stereochemistry. That said, the common mistake I saw in all the discussion board posts, count your carbons. A lot of you are like one carbon off with all your positions. All right, let me respond to just a couple comments I'm getting in Teams, and then, yeah, here to answer any questions you might have. Of course. Can we run through a couple of RNS naming problems? I don't have any specific ones. I would just like to go through a couple more examples. I'm still struggling with those a tad bit. All right, so let's just do some random ones. So for R and S, this is kind of the last thing you would do when you name any compound. So with naming any compounds, you always just kind of start as you normally would. So for this one, we have 4. This is butane for the parent chain. 1, 2, 3, 4, 5, pentane. And then pentane down here. Name your carbon positions. In this case, we're trying to minimize the alcohol. So this is going to be, instead of butane, butanol. 2 butanol. 2 chloropentane. And then 2 chloro. 3 methyl pentane. So the RNS are going to show up as you get towards the end of naming these. Now, you're going to need an RNS for each chiral center. And just because you see stereochemistry doesn't mean it's chiral. You do need to go through and verify that quickly. It's chiral if all 4 different atoms, all groups connected, all 4 groups connected to the carbon are different. So these are kind of easily drawn. If you only have one chiral center, you're going to lead with whatever the chirality of that center is. If you have 2, you have to number each chiral position in order. So the second and third carbons are chiral and specify their chirality. Now, to figure out if something is R or S, we simply number the groups. So for this one, OH has the highest atomic number. It comes first. We have carbon and carbon, hydrogen. Hydrogen's the lowest atomic number, so it's the 4th priority. If we have two things with the same priority, we look at what's bound to them. So this carbon has 3 hydrogens. This carbon has a carbon and 2 hydrogens. Since the first difference is carbon, this ends up being the second, and this ends up being the third. Now, there are lots of ways we can approach this, but the big thing is we need to draw the structure in such a way that the lowest priority goes back into the board. In this case, because the hydrogen is wedged, it goes back. We look at it, 1, 2, 3. This is a clockwise rotation, so this makes it the archirality. Chlorine's going to work the same way over here. Chlorine's the highest priority, hydrogen's the lowest. We have 2 carbons. This carbon's bound to carbon, 2 hydrogens. This carbon is bound to 3 hydrogens. The first point of difference is carbon versus hydrogen, since that has the highest atomic number. This would be the second priority, and this would be the third priority. Because the hydrogen's already back, we just rotate it. This goes counterclockwise, so this is S2-chloropentanol. For these two, chlorines, if we look at this first group, we have chlorine is the highest priority, hydrogen going back to the lowest priority. We have a carbon bound to 3 hydrogens. In this case, we have a carbon bound to 2 carbons and a hydrogen, so this ends up being number 2. This ends up being number 3. Now again, because the hydrogen is back, we can do this. If the hydrogen was actually coming out, it would be the reverse of this order, but it goes 1, 2, 3. Since it goes counterclockwise, the second one is 2s. For this one here, the methyl, we have a hydrogen going back as the lowest priority. We have a carbon, carbon, and a carbon. So what we have to do is look at what's bound to these carbons. So this carbon is bound to 3 hydrogens. This carbon is bound to a carbon and 2 hydrogens. This carbon is bound to a chlorine, a carbon, and a hydrogen. So if we look at the first point of difference in all 3, chlorine, carbon, hydrogen, this has the highest priority, this has the second highest priority, and this has the third highest priority. Now again, because hydrogen is going back, we can kind of look at it and do it as is. If the hydrogen was coming forward, it would just be, we would have to flip this molecule around to make this work. But since it goes counterclockwise, 1, 2, 3, this all ends up being 3s. Yeah, you're very welcome. Any other questions out there?
There it is.
Ooh, Stanford was a terrible place. Um, yeah, get used to dealing with a lot of rich kids. And yeah, would not recommend Stanford. I mean, power to you, but I really would not recommend Stanford. Keep in mind they had to devise curriculum for students in the design school because their students conceptually didn't understand poverty, like genuinely did not understand how poverty worked, and really believed that the solution to poverty was everyone borrowing money from their parents. Like I'm not joking. There is a massive disconnect between the Stanford student population and the world. Yeah, they buy it from you for really cheap, and then they go to their buddies and they mark up the price a lot, and then they sell it for way more than they bought it from you for. All the while wondering why, poverty is a thing, right? Why you just didn't borrow more money from your parents. Actually, the whole like art appraisal thing is like really sketchy. But anyway, oh, and yeah, if you're going there for school, you're going to be objectively poor. Like, I can say if you live in East Palo Alto, if you can, at least the rent is something approaching reasonable. I think I paid $2,000 a month for a one-bedroom apartment while I was out there. Yeah, it's really a shame. We do need the arts. Like, I think art inspires science and science inspires art. There's a great interplay there. Um, Somebody once did a discussion about all the technologies that were inspired by Star Trek, like flip phones, communicators, all that was like really based around those ideas. And I really view art as a very good way of society kind of reflecting. Watched a lot of really good video essays on how our fears are reflected in our science fiction writing, and you can see shifts in. Yeah, but I'm talking like a 600 square foot, and this was not a nice apartment complex. It was technically gated, and I say technically because the gate was broken half the time. But to go across the street, literally cross the street into Palo Alto, your rent went up to $3,000 a month, and it's not uncommon for people to be renting out their garages for like $2,000 a month. There is no rent control in the Bay Area except for East Palo Alto. Now that may have changed. I know there was a lot of lobbying going on to get rid of rent control, but yeah, I would not recommend the Bay Area. Like, it's a great place to visit. There's some fantastic hiking if you're willing to drive an hour and a half. But yeah, would not recommend Stanford. Gorgeous architecture, gorgeous campus to cross. I would not say their students were particularly smarter than any I've met at most other universities, and I've worked at a lot of universities. You're most likely there for the networking. That's about it. Well, on that note, we'll cut it off for today. Keep in mind tomorrow is Faculty Professional Development Day, so there's no labs on Tuesday. Wednesday we are off for holiday, so no live streams, and I will see you all Thursday.